why AI is important. Well, first of all, I think all of us faced really big and powerful, I would say, rise of AI everywhere. Everyone has been using and advancing in using, generative pre-trained transformers, meaning GPTs, that are in my mind all over the place. So everyone uses that for daily life, for kind of speeding up process of finding information, of having things fixed and stuff like that. So basically, last year we were all impressed of how fast it took over. I would say classical search engines, and this year, according to some industry professional predictions, we're gonna see how actually Gen AI gets into more narrow and specialized applications. So we will be stepping away from the GPT models that are kind of too generic and used as kind of search engines mostly, to more, I would say, to customized GPT models that can be trained to support your actual need of working with the big amount of data. So what happens basically in the industry, that's at least what we can see, is that people are more and more adopting AI, starting with big organizational process and needs, and then obviously it will be moving down and down to embedded products, and that's mainly because embedded products are also pretty resource capable today. And one of the, I would say, one of the subclasses of connecting AI as a big term and also big data processing is machine learning, basically. So that's a class of tasks, that a class of technologies that helps us to train and create the models based on some big data we can harvest from the business application, and then we can put that data to the edge computation devices. So we are not, like previously, we are not transferring data back and forth to the cloud, but we can actually do a lot of calculations and a lot of data analysis right at the edge. So if you look into, I would say, the process of AI adaptation in the companies, what basically happens? Well, the process is pretty, I would say, typical for all new technologies that we're booming. We can actually, remember many, starting from actually having, FETs or MOSFETs coming up in the industry. First of all, of course, we learn, we explore, we do some greenfield exploration process, like, okay, how we can use the technology. And that's, I think, where we actually already advancing pretty much. So we adopt AI tools to our daily lives, and we can actually see what we can gain here and there. So we transforming, or we're moving on to the using of AI utilities. And if you can see, if you can check in your industry, basically AI is just developing everywhere, from project management to things like writing the embedded software code for you. So that's the usage of the already available AI utilities or tools out there. And the next step normally is embedding tools into your organizational processes. This is where you actually see a lot of different complications related to security, related to actually how do you train models using publicly available data, how you train models with your organizational process assets and knowledge assets. So a lot of different challenges are in embedding the AI into the process. And then you move to the next phase that is called mastering. So what happens is here is that you create, I would say, an AI-based internal, I would say, mechanisms that are helping you not only to embed AI into the products, but also generate new products. So you can see with AI, with big data, you can see stuff that you have never seen before with your products. You can also predict and kind of pre-plan where your products can go in a few years. So that's the process, and that's why we have quite a few dots pointing out from the line here, from the straight line here, because that's the way you kind of develop, and that's the way you kind of grow inside the organization with the products. So that's a little bit kind of too generic, but how we can actually use AI in the projects? Well, we have pretty few domains where it's already used, and it will be more and more used here and there. Well, healthcare obviously is probably, I would say, the most hard to penetrate, but very fast growing. And the hard penetration here is related mainly to the regulations and different, I would say, type testing certifications related to actually the safety of technology. We have robotics because we can obviously minimize the amount of traffic between the autonomous machine and the backend, so to say. And then we can also push more and more decision making to the embedded part, meaning to the robot. We have different complex tasks like inventory management, where we need to analyze a lot of streams of data to be able to actually make a decision. Agriculture, where we can have a lot of different use of both animalities, but also use of different kinds of, I would say, detection of either pests or diseases that you cannot actually, using the standard algorithms, you cannot predict in an easy manner. Smart homes, and that's actually where we will demonstrate our case today, where you work with climate control, energy consumption optimization, stuff like that, and obviously production, continuing the idea of Industry 4.0 that now kind of reaches out to Industry X0. Let me put it this way. So these are the typical, I would say, areas where I would suggest you to look when you consider adaptation of AI and in particular machine learning. So how we actually grow or leverage up the business value by using this? Well, first of all, we can move products to be more secure, both from cyber security perspective, but also functional safety, meaning that we can actually let our products to be more data anomalies detection capable. So we are not necessarily programming huge algorithms to try to kind of manage all the branches of the algorithms that might go wrong, but we move to more data-driven models to actually catch that. We can use AI to optimize the performance, meaning that we actually do, I would say, more end user use cases logic rather than predicting how users can use our products. We can also go to the better data awareness. That this is where AI or machine learning connects to big data and IoT. So we are pushing more data out when we need it, so we can actually learn how customers use our products. And then we can also, based on all this, we can get more insights saying, okay, actually, this is how the product shall evolve later on. So we can concentrate on evolving the business value we need instead of just, kind of suggesting or guessing what kind of product future we can have. So the case study we want to continue talking on, like we were continuing before, is the product we call Cleaning Observer. What is this? This is a set of sensors, and that's why it represents one of the subclasses of, I would say, machine learning tasks called sensor fusion. What it means in short is that you have an amount of sensors, and instead of classical, I would say, algorithmical approach to it using some sort of Kalman filter, for instance, to get some kind of correlation programmed into the classical algorithmic way of solving your task, you do analysis, you do data collection of this sensor fusion as a subset of specific sensors. And based on that, you can actually quantify and label your data to see what is happening. So what we used in this case is, first of all, we used the STM32H7 dev kit just to play with the data collection, because we already had actually the model that was proven on a slightly different hardware piece as a proof of concept for the customer. So, and then we used a 30 minutes window for data collection with a running stride of 10 seconds between the samples, the data samples. We can kind of, we were data acquisitioning with 10 seconds frequency. And based on that, what we wanted to know, we wanted to assess if in a multi-room premises, let's say office space or a hotel, we can say to the end, I would say not to the end user, but to the manager who is in charge of actually assessing how the cleaning is done. We wanted to send one single bit of data, if cleaning was good enough or not good enough. So what we used for that, we used a deep learning model. So that will be explained a little bit later, how it works. And based on that model, we have kind of used for the data processing, we have moved to the deployment on the actual platform, and this is where we actually used the Cube.AI. That was the outstanding performance in our case. So that's the model, and that's the case study we want to use for today's presentation. And if you follow the previous presentations, you have been actually seeing the performance we have reached with this approach. So you can actually go back and by using the feedback form in the end of this webinar, you will get a link to review the previous slides as well. So now I am actually pushing microphone to Darina, our data scientist, who can explain a little bit more on how AI looks from inside out. So please, Darina.
Yeah, hi, thank you all for coming. I'm Darina and I'll be talking about neural networks today. So what is generally neural network? It is basically just layers of different complex operations stacked on top of each other. They all have input and output, and inside of it, in these hidden layers, they have various combinations of different structures, operations, some of alternate, some of not, etc. They all perform complex operations to understand the data, to find these patterns we are willing to see. So naturally, as the layer number increase, the complexity and the memory that it takes increases as well. In this case, we use techniques such as quantization to reduce memory footprint from flash and to make them accessible and portable into small devices, into MCUs. So how can we actually optimize all these big models and make them possible running on small devices? There are four main techniques, and of course they are not describing the whole pool of available techniques in size reduction, but we've decided to show these exact because they are the biggest, the most popular techniques to do so. So first one is post-training quantization. It is a technique that is usually applied after model training and after everything is already done. What this technique does, it just converts floating point values into lower precision fixed point numbers. And because of this conversion, we can lose in accuracy, for example. But we can save the situation with employing the next technique, which is called quantization-aware training. Instead of quantizing, instead of conversion of our floating point values after training, we can already train our model with implementation of this technique. So you can basically see here on the picture how it looks like. We have our weights, they're in a floating point format. We quantize them, retrieve some integers, for example, and then calculate the response, calculate the loss function, which signifies how bad we've guessed our target. Then we receive this feedback, calculate gradients, and adjust our weights. After that, we again loop all these calculations until we receive our best model, which is both good in terms of accuracy and does not require that much space. The third technique, this one also applies after training. It is called pruning. It's basically just cutting or deleting redundant connections, neurons, or waste out of our neural network. And distillation, it is the final technique. This one is more complex. It involves having two models learning simultaneously, teacher model, which is way bigger in size, and a student model that could be actually ported into small devices. So how it works, the teacher model transfers knowledge to a smaller model and calculates error between outputs of bigger and smaller model. And based on this error, we adjust student model weights to mimic our big model. And talking about optimization, Cube.AI provides a great tool which is called, STM provides a great tool which is called Cube.AI. They help with quantization, but it is a post-training quantization. So first you have to have your model, or maybe you can use STZoo to retrieve a model. They provide a really huge variety of already pre-trained models that are available for porting on your targets. And then after running it through this extension pack in CubeMX, we can receive a template, a code for your chosen target.
So now, thank you, Darina, for this introduction, for bringing us back to the theory a little bit. So now we know the connection between, I would say, the idea of machine learning and AI, theoretical knowledge, and how actually it fits into the Cube.AI and ST's model Zoo, so to say. The way it's called Zoo because it kind of represents a variety of different models you can just use off the shelf. And that's a really good one. So now I want to have a ST expert actually to telling us a little bit about why and how ST became an outstanding player in this actually ML market, and that's why I wanted to welcome Mr. Nicholas Gouda to make the presentation. Nicholas, the stage is yours. Let me just transfer the screen to you.
All right, thanks a lot, Alexander. Hi, everyone. So yes, I'm Nicholas Good, Product Marketing Manager at ST Microelectronics for ST AI Solutions to deploy AI on STM32 microcontroller and microprocessor. So you should now be able to see my screen. So I will just start the presentation by some high-level, let's say, marketing figures that will perfectly echo what was said before by Alexander. At ST, we are also witnessing a really rapid adoption of edge AI or embedded AI. This is perfectly illustrated by this survey that we did last December, So in 2020, we had only 8 or let's say 5% of our users, STM32 users, considering Edge AI for their project or using Edge AI for the project. In 2023, as you can see, this has was now 40%. Okay, but also what was said in this survey was that the remaining 60%, 80% of them was actually considering Edge AI for their project for 2024. So this is perfectly illustrating, okay, the rapid adoption of Edge AI. Again, it was mentioned before, but definitely Edge AI will transform both the product, but also the associated services. So the devices themselves, they are undergoing some evolution. We are adding functionality, they are becoming more energy efficient, and they try to make the life of their user easier and safer. But the product that will embed Edge AI will actually have a significant advantage over those that do not embed Edge AI. And also the business model itself will change, and that change can be even more dramatic, because with the ability to process the data locally in real time, that can be done at the fraction of the cost of cloud-based solutions or services. Edge AI combined with security and connectivity will be the real key enabler for industrial digitalization. So the company making equipments and also others, it will bring them the opportunity to build new service offerings on top of what they were doing today. But with that being said, okay, deploying Edge AI within an embedded project is not that easy. Why is that? Because on one hand, it will require some specific expertise, so Edge AI expertise or AI expertise, embedded software development as well, and obviously some data science or data expertise. On the other hand, the hardware we are talking about here, okay, it's a really small devices, so power consumption has to be low. Memory footprint or the memory available within the device is quite small, and we need to have almost real time, so meaning the inference time has to be low as well. And without the proper tools and the proper solutions to deploy such a project, it can be really a nightmare. So this is why at ST, okay, we have worked for more than 10 years now to provide both a comprehensive software stack or software tool chain of solutions, but also some hardware to support the rising use cases of Edge AI. So looking at the software, what we have is that we are providing solutions for any type of applications that you can consider. So be they time series applications or audio applications or even vision applications. And for that, we have specific tools. So one of them was presented in the past webinar. Today, I will explain a little bit more about Cube.AI, and we also have specific solutions for microprocessors, so MPU, in order to deploy AI on these devices. And because, as I said, okay, software has to be supported by also very good and very efficient hardware. We are working on expanding our portfolio of hardware products with new hardware accelerated product for AI. The first two of our portfolio will be the STM32 MP2, which is a microprocessor with AI hardware acceleration. And soon after, we will have the STM32 N6, which is the first MCU with a hardware acceleration for AI. So if I zoom a little bit within the STM32 Cube.AI solutions that we provide, okay, not only we provide a tool to deploy AI, but it's more an ecosystem in order to solve all the challenges that a developer can encounter during his project. So we have the historical, if I can say so, Cube.AI plugin, which is part of the CubeMX development flow. But more recently, last year, we released STM32 Cube.AI Developer Cloud, so which is basically an online version of the Cube.AI plugin. The experience is a little bit different. It is also targeting different profiles of users, but it's using the same technology. This developer cloud is relying on a board farm, STM32 board farm. So this is basically STM32 hardware, so real STM32 microcontrollers and microprocessors hosted in the cloud that our users can access to benchmark the performances of their models on real hardware without having the board with them on their desktop. And also the model zoo, so STM32 model zoo, which is a collection of AI models, scripts for deployment and quantization to make sure that we support our users with the right model and scripts for embedded AI on STM32. Because as I said, these devices are really constrained. So zooming again a little bit more within Cube.AI. So what is it doing actually? So it can be seen as an optimizer or a compiler for trained neural network models. And these models, they can come from any major frameworks, AI frameworks. Okay, so it can be TensorFlow Lite, Keras, or other frameworks can be exported as ONNX models. These models can be either quantized or non-quantized. Okay, obviously quantized is always better, as it was explained by Darina before. And what the tool will do is that it will first analyze the model, checking for any possible optimization. It will perform this optimization and validate that the new optimized model still has the same performances as the original model. And if that is okay, then it will generate equivalent C code for the model, C code that can be then executed on the microcontroller. So we will provide both the C code for the model and also some library, kernel library with optimized functions that will be used inside the C model. What else can I say? Yeah, inside the tool as well, you can generate directly the project that can be used in your preferred IDE so that you can, develop the complete project and not only the AI part. And then you can compile that with your compiler and deploy it on the microcontroller you have targeted. So we are providing various KPIs such as the inference time per layer, how much memory is needed per layer, so that if you want to fine-tune your model to make it really optimized for embedded devices, you can do it. Just quickly mentioning here that, as I said before, the tool is actually available in two flavors or two versions. So we have the plugin for STM32 CubeMX, so which is the desktop version. This one will mostly target embedded developers because it's really part of the embedded software development world. But for data scientists or AI engineers, in order to make their life easier, we are providing the STM32 Cube.AI Developer Cloud, so which is an online platform in which you will really quickly upload your model, okay? And with only a few clicks, you can select the hardware on which you want to benchmark it, and you will get the performances of your model on a real hardware. Then you can decide either to generate the C code for the model or even a performance project that you can include within CubeMX, STM32 CubeMX. Just to finish, what is really happening under the hood within Cube.AI. So as I said, what we do first is an analysis of the model, and we will perform some graph optimization. So obviously, this graph optimization, they will not degrade the model performances. So we'll check if we have nodes or operators that we can merge. We perform some auto graph rewriting, constant folding as well. And again, we are validating these changes against the initial model. Then we have the support of a quantized model. So either you use your non-quantized floating model, floating point model, or you can use fixed point quantized model that has been quantized using traditional quantization tool, such as TensorFlow converter or ONNX runtime. And also, so we provide memory optimization options. So you can decide whether you want to optimize the model for speed or for RAM size. And then you have a view of how the model has been positioned within the STM32 memory. And as I said, which size has been taken by each layer and what you need for weights and activation. Something actually quite important I want to mention before closing my presentation is that everything we provide within our AI ecosystem is actually free of charge, okay? What you need is just a myst.com account. You log in, you download the plugin, or you connect the online interface, and you can use the tool directly without any contract or any license agreement to be signed. Yeah, I'll skip that. Okay, and just to tell you that we have more information about our tools, all the use cases that we support. We have some examples on the website dedicated for AI, so which is stm32ai.st.com. And also we have a specific email address in the events that you want to reach out for sharing your project, asking any questions, and so on. And yeah, thanks a lot.
Thank you, Nicholas. I'm taking back my host to share my screen again. Great presentation and obviously great information. So let's continue our presentation. And I'm handing over microphone to our embedded development expert, Mike. So Mike, the microphone is yours, so please go ahead.
I'll a bit repeat things that were told by Nicholas. So Cube.AI is a part of big CubeMX STM32 CubeMX ecosystem. It's a pack in that ecosystem, and it's used for analysis and porting the pre-trained models. It makes model porting much simpler compared to some other vendor solutions. There are two modes. There's local mode and cloud mode. Local cloud mode is more for data scientists, and local model is more for embedded developers. On the right side, you can see the typical flow, and we will describe some those steps a bit precisely a bit later. First, we take the model, upload it. We use TFlight, Keras, or NNX models. We upload it, and first we make analysis of it to check that we can fit ROM and RAM footprints. Then we can make some optimizations and validate the model. You can validate the model on random data or using your data. Validation can be done as on your PC or on the target board. Here's a bit practical. First, you need to select the application type. It can be system performance, validation, or application template. System performance is for benchmarking. Validation is for testing that your ported model works as expected. Both of these are fully automated. The project is generated for your installed Cube IDE and automatically uploaded to the board. So you don't need to do anything except several clicks. And application template is done for your software development. It also has model installed, so you need to implement only several functions. Of course, you can change a lot of things, but still you need to implement several functions. First is the acquire and process data. It's a function where you pre-process your data. For example, it's got from sensors, or as in our case, it's just replaying it from the SD card, from pre-recorded on the SD card. Then the model itself runs. And next, we need to post-process data that is got from the model. For example, we can turn on the LED showing that, okay, the cleaning was done, or just write something onto your SD card. Optionally, you can add some initializing or something like that. More precisely, we'll show it in the video.
So first we need to add Cube.AI back to our CubeMX. Our board is configured, selected and configured now. Here we are, select core. Here we have several options. System performance and validation are for automatically running several profiles on board, and application template is for writing our code in it. So we select application template. Here we are. Now we need to add our pre-trained network to our project. Selecting TF-Lite and naming our network. Now selecting the TF-Lite file from our local file system. Here we are. And now we need to analyze our network. Done. Now we check that our network fits, our precompiled network fits our flash and RAM. We see that we surely can fit it. And now generating C code for it. At this stage, it will generate source code and library containing Cube.AI processor and our network. Done. So we can see that moving our network to embedded board is rather simple. Now we can switch to our IDE to compile and put the binary to the board. Here we are. We are using C-Line IDE as our corporate standard, and it is rather smoothly integrated with STM32Cube, MX, and all other Cube ecosystem. We need to implement several functions. The first function is that gives data to the model. Here it is, acquire and process data. And next we need to implement the function that post-process that processes the output of the network. All other is done by CubeMX. So now we are running CMake. And next we will build the code. We are using not real sensors, but simulated data put to the SD card, and it's passed to our network using this windows for every 30 minutes of data. Here we are, now we are building and putting the binary to the physical board. Here we are, and now running our build project. Now it's put on board, and we can switch to our serial console to check that it's working and processing data. Here is our serial console that is connected to our board, and now we can see that software is working and processing data. Our window size is 900 of measurements. It's 180 measurements and 5 sensors. So now you can see that the data is successfully processed.
So that's a very simple video demonstration of how easy it can be integrated. And actually, you have in the source code, you have all those parts where you need to actually put in your lines of so to say logic or whatever else you call it, and then it can also be pretty easily integrated with the rest of the application. Now to actually compare the experience of working inside the Cube.AI as part of the STM32AI ecosystem, we want to bring a little fast but still clear comparison of how it actually compares to the Nano Edge that was previously also presented by Nicholas. So I would like to hand over the microphone to Darina to actually share some of the ideas and experience we had. Please, Darina.
Yeah. Okay, so throughout the webinars, throughout the whole series, we've built some solid knowledge about deep learning, AI, and ST tools that could assist us on this journey. First, I'd like to start with talking about the intention of these tools. They are quite different. Nano Edge covers pretty everything from data collection to deployment. It can as well generate code for data collection, but if you need some, but you can anyways use your own data as well. Whereas Cube.AI only covers all this post-training optimization process and build process, deployment. It's at first glance, Nano Edge seems to be a perfect tool that could do everything for you, but it has its own limitation. First off, initial models requires minimum 50 signal samples per class you're observing. And secondly, computation time and all these model training, so to say, but in fact it's just a library selection, might take a lot of time if you don't have enough cores allocated or memory on your training device and the laptop you're using or computer. However, they still provide a good firmware template, quite alike to the one that Cube.AI produces. And talking about decision, which tool to use in which case, right? I'd like to show you the next diagram. It is a very simplified diagram, but you can easily see here that first off, we need to take care of data and then start working with a development of a model. To decide which tool to use, we can use this simple steps. First, we define whether data is numerical. And if it is by numerical data, I mean, if it is time series or something that is not videos, pictures, speech, we can easily use Nano Edge, but we need to make sure that these data does not have trends or seasonality. If it does, it requires a lot of preparation beforehand, before starting to work on a model development. And then we need to make sure that your task aligns with all the available project types in Nano Edge. They support only anomaly detection, classification, and extrapolation projects. Therefore, if you want to make some video recognition models, you'd better go for Cube.AI. But in this case, you'd have to develop your own model or use one that is available in STZoo repository. It is quite easy to use, however, it requires an ML knowledge, and in this case, we can help you. If you have some questions or difficulties working with your data or developing your own model, even alternating the existent one to suit your needs, you can simply contact us and we will give you a hand in this process, because it is quite a knowledge and time demanding process. So yeah, I'd like to ask Alex to continue.
Yeah, thank you, Darina. So basically, that was, I would say, the main comparison kind of graph we wanted to show you how to choose the proper tool. And we have been using both tools with it's their own pros and cons, I would say. But both tools are pretty nicely made. So I want to wrap up the webinar and actually kind of highlight some of the important, I would say, executive summary from today. First of all, I think we have been covering that Cube.AI really simplifies machine learning work. So it's really the tool you would want to use, and you can use it for deployment. You can have ST-Zoo for ready-to-use models, so you can actually start from something already tested and proven in use. The second thing that I want to mention is actually, we have been working with quite a few tools for different vendors, and I would say that ST ecosystem is the best what we have seen so far. So, and it's really the tool chain to work with. That would be my recommendation. What is important also when you consider machine learning projects is to have someone knowledgeable next to you, because scratching the surface and starting from real scratch, from real blank sheet of I would say of paper is a little too long and troublesome, and we are all pressed for time to market. So actually it's really important to, in my mind, it's really important to concentrate on the business value of the product rather than trying to get through all the tools, and this is where we can help you. I would say still, as one of the biggest considerations, I would recommend to do is that you need to understand your data. Doesn't matter what kind of model and what kind of task you're solving. It might look extremely simple. You might think that, well, it's just around the corner, so you just apply data to the model and then you get it fixed. That's all correct, only in one situation, when your data is good, prepared, and actually you have the expertise to get it aligned. And that's extremely important. You can basically try it in a way to to ask some nonsense using ChatGPT, and then you will see that basically you will get a nonsense in return. So that's kind of the same problem here. And I normally call it, like you use junk data, and then junk data generates the junk knowledge. So that's a short wrap up for what we have been seeing today. Obviously, the tool chain is pretty straightforward. For those who worked with ST ecosystem, all will be pretty standard. So I don't see that you will be, really facing some challenges, something totally new. Some of the tools will be definitely new and will require some, onboarding time, but that's I think pretty possible. So now I know that we are a little bit late, but I want to get any of the questions. If you have any, you can put them into the chat. I don't see anything in the chat right at the moment, so, or you can just unmute yourself and ask the question. I think we have time for, a couple of 2, 3, 4, 5 questions here. So please go ahead if you have any. And
By
while
that, don't forget to check for our form
Yep.
in the comments.
Yes, we normally we appreciate your feedback on the webinar, and for those who will fill out the feedback form, we will be sharing the links to the previous webinars and as well as this one. So we really want to get better with what we present. So we are eager to let know what you think. So any questions? Anyone with some ideas, or was it really too complex to kind of consume this information during this afternoon?
Hello, do you hear me?
Yep.
First of all, thank you for the presentation, and I have a question regarding, you mentioned NanoH and Cube.AI. So let's speak about some real case. And for example, having a task to add in existing product some AI feature. And for example, in this device, I have 1 or 2 digital sensors. What the tool suits me best, NanoH or Cube.AI?
Darina, can you take this one?
Yeah, sorry, could you repeat the question, please?
Yeah, the question is, I have 1 digital sensor, and some moments in real life need to be happen and need to be catched and identified, and which the tool I need to use.
Yeah,
NanoH
first off,
or...
do you have ML experience?
No, I don't have ML experience.
Then you'd better go with NanoH solution.
And if I have such experience in ML?
If you have such experience and you have enough of time to drown into this sea of data exploration and model development, then you're free to go try out Cube.AI. It is a good tool that would definitely help you to optimize your model and make it possible to run on a small device.
Okay, so this is more about your skills or about the data and, for example, sensors that you have?
It is both. Well, it depends on your data. If you're, for example, not measuring, but trying to predict some anomalies, for example, if we have a motor running and then something happens, then it is a good use case for NanoH solution. But if you have some data about weather change or something is not, which have trends, seasonalities, or not that easily distinguished, then you'd better make your own solution using code and not pre-made tool as NanoH is.
Thank you, Darina. We have one question in the chat from Mr. Vadim asking about if you can provide some cases where it can be used for safety. Well, I can take this one. Basically, the way machine learning can be used for safety is very simple. If you're looking basically for protecting some of your assets or some of your, I would say, products by ML, you can always look up for some anomalies. So you can look up for anomalies in patterns of using the product, of patterns of data that comes in and comes out of the product. And based on those anomalies, you can obviously figure out if you have a regular, I would say, use case for the product, or you have something wrong. You have some kind of destructive data flows in and out. This is how the majority of modern so-called next generation firewalls are built. So you have AI ML models sitting in the products that are trained by the I would say wrong behavioral patterns of TCP/IP packages that are coming in and out, and then by decoding those anomalies or trying to look for some, I would say, detecting specific sequences of anomalies, you can then protect your end users from being compromised, so to say. So that would be one of the simplest ways for me to describe where it can be used for safety. In this regards, it's more cybersecurity or cyber safety. So that's what I can say.
Okay, so it is not about functional. It is not about functional safety.
No, it's not about functional safety. Okay. I cannot just come up with a super fast example, but I'm pretty sure I can reach out to you later to share my ideas about functional safety. And then there is a question in the chat about advantages.
Thank you very much.
You're welcome. There is a question in the chat. What are the advantages of running the model in the cloud versus on a laptop? Well, I think with Nano Edge, at least you probably can only run it on your PC, at least according to my knowledge. And then if you're using the Cube.AI, then you can obviously train and also qualify and validate a model in the cloud, like Nicholas explained, with the majority of different hardware, ready-to-use hardware. You can place a model basically.
I can add a bit that when you run it on your local laptop, and you have installed Cube.ID, the automatical part is done fully automatical. It's even flashed to your board. If it knows about the board, if it's STDemo board, it automatically flashed and run. So you just need several clicks. In cloud, you need to put that model, open it in your IDE, compile it, etc.
Understand. Well, in the cloud, you can also deploy it to the subset of processors, and that's a relatively new feature. I don't think we actually tried it.
For the ST farm.
Yeah, ST farm, exactly. So basically, there are no more questions. So I would like to thank you all, to say thank you all for joining this evening. I would like also to have my I would say appreciation to Mr. Nicholas Gauda from ST. And I would like to stress one more time that if you have a super complex case of machine learning where you are struggling to find the solution, you can reach out to us. You can reach out to a very powerful ST team, and we together we can solve your problem, and we can help you to get to your final product faster. So that's the final word for this evening from me. Anything from you, Nicholas, as a final word?
No, I just want to thank you and thanks everyone attending the webinar. I hope it was helpful. Edge AI is definitely a trendy topics, and that will unlock new use cases and new business cases in the coming year. So hopefully we will find extremely successful projects together.
Super. Thank you very much, everyone. I wish you a wonderful evening, and let's stay in touch for the new webinars. Bye-bye.